Right, guys, I'm gonna fix this camera really quick. Cool stuff. So welcome to Mod 6 Review. Here we go. Starting off, we got this polynomial function, not a polynomial function. Most important thing is these exponents here have to be integers or the number 0. We call those the natural numbers with 0 included, or the integers with 0 and above. In other words, you cannot have decimals or fractions or variables in the exponents. So we're going to go ahead and say this guy is a no right away because of that guy right there. Automatic no for polynomial. Whereas this guy is a yes. And because it says yes, state degree and leading term. Degree is 6 because this 6 right here. And the leading term is that entire guy right there. Negative x to the 6th. And again, the degree is simply the largest exponent value. This guy's a no because we have a fraction right there. Where please note, you're allowed to have fractions, but you can't have a variable in the fraction right there. So that x right there, that kind of really means negative 9x to the negative 1, and that's a negative exponent. That's no good. This guy's also no. Again, we cannot have variables in that exponent. No good. This guy's good to go. We have a leading term of 7x to the 5th, and that means our degree there is 5. Our degree is 5. This guy's deceptive. The answer is yes. The degree is 0. It's kind of 0 because there's an invisible x to the 0 right there. Remember, anything in the 0 power is 1. Anyways, that leading term is just 4. And you can write 4x to the 0 if you wanted. Not that big a deal. These guys, all of our end behaviors, every single one of these, we want to go ahead and remember one of those main little charts. The way I taught it in class was this guy. We had our evens here, our odds here, and our positives here and our negatives here. And we're talking about the leading term. And when I say positive, I'm talking about that coefficient in front. So like this guy up there is the 7, makes that positive. This guy over here is a negative, makes that negative. We're not talking about the exponent. The exponent is only for the even or odd part. Even exponent, odd exponent. And we draw this little guy here, this little guy there. And then the odd kind of looks like this. And the negative looks like this. So we're going to use that in just a moment here. So let's look at this guy. Leading term, negative 2x to the 6th. Again, the reason why is it is the largest of the exponents. So there's our leading term. The end behavior. Every single time you have end behavior, you're going to describe it in two ways. The limit as x goes to infinity, as x goes to negative infinity. In English, we said as x goes to infinity. Another way of saying that is as x increases without bound and as x decreases without bound. In layman's terms, this one means as we go to the right, this one means as we go to the left. We now use this chart over here to help us out and figure out what's going on. As x goes to the right, we have a negative even. So negative even, we're looking at this guy. It goes down on both ends. If you go to the right, you're going down. If you go left, you're going down. So f of x, the y value, is approaching negative infinity for both of these. Not that big a deal. So the leading term, when it was all multiplied out, it was this negative 2x to the 6th. But if I jump down to, say, this guy, we have to look at the leading term a little bit differently. So the leading term is going to be this x, and then this guy is really x squared. So it's kind of like x and x squared. This guy is really a 2x. This guy's really an x. And if we multiplied all those together, we'd get x times x squared times 2x times x. That's going to be 2x to the 5th power. So it kind of ends up being this 2x to the 5th power. There's our leading term. Before I describe the end behavior of this one, I want to do end behavior. I want to do the leading term over here. It's going to be negative 4x x squared. That's a negative 4x cubed. Again, end behavior for both of these. As x goes to infinity, as you go to the right, x goes to the left. Again, the fancy way of saying that is as x increases without bound, as x decreases without bound. It gets very large, it gets very negative. One of the two there. And again, you're going to have f of x going to, f of x going to, f of x going 2, and f of x going 2. And again, we use our chart over here to figure these out. We have a positive odd. Please note, even though this is an even number, it doesn't matter. It is a positive number, odd exponent. Positive odd exponent, it goes up on the right-hand side, and it goes down on the left-hand side. Oh, I wrote that in the wrong spot. Oh my gosh. This guy is actually the upside down of this. In fact, apologize about that. This one's the negative 4x cubed. So that negative in front means we are in a negative odd situation. That means it's actually going down on the right-hand side and it's going up on the left-hand side. So again here, number 3, same exact idea. As x increases without bound, f of x decreases without bound. We just talked about that same exact idea up here. We sketch this graph over here. I don't really need to cover this, this guy. It's the same exact idea. Now we're moving on to page number 2. As requested, shout out to Naeem. He wanted a shout out here, so there's that shout out. Don't really know why he wanted a shout out, but there it is. We covered these guys in class just today, and because we covered those first 3 in class, or at least the first 2, I'm just going to cover this last one over here, this letter D, because we only really need to do one of these guys. The thought process is going back to this same idea we did in the previous page, this guy. We notice that both ends on the left and right hand side, the left and right hand side both go down. That makes this a negative x to an even power. We're going to use that to check our work at the end, but no matter what, both of these guys are going to have a negative in front. The question asks us to make 2 different functions that could be represented by the graph here. So we're going to go ahead and mark these roots. We have a root of negative 2. We have a root of 1. We have a root of 3. This root of negative 2 creates a factor of x plus 2. This 1 creates a factor of x minus 1, and this 3 creates a factor of x minus 3. However, this one's a bouncer. It touches the axis and bounces right off. So we're going to write negative x plus 2 quantity squared. Any even power would have done there because of that bounce. Whereas these guys both cross through the axis, so they're both going to have odd powers. Awesome. One's both odd powers. Please note, I could have put a 4 here or a 3 there. You know, doesn't really matter that much, but I think really an exponent of 1 is most accurate because it goes straight through instead of having a little curvy through it. That would really be a 3. So just leave it like that. And it says create another function. So instead of having a negative 1 in front, how about a negative 2 in front, or a negative 3, or a negative 4, or a negative pi? It doesn't matter what number you put in front, as long as all of the roots are exactly the same. Not too bad. Number 5, factoring. So factoring, really just got to practice this a whole lot. We got to make sure we write it correctly. And different strategies for every single one of these, really. I'm going to cover basically these first 5. We're going to do some more factoring later in the packet anyways. So this guy here, we're going to factor out an x first. Again, we took one x out of all of these, so that x cubed became an x squared, that x squared became an x to the 1, that x became x to the 0, x to the 0 is 1. After that, we ask ourselves what multiplies to positive 1 and adds to 2. In this case, it's nice and easy. Positive 1 and positive 1. And we're going to write that in the better way of x plus 1 quantity squared. Easy enough. Tells us it's a double root or a bounce. Moving on to letter B. On the test, this question is multiple choice because it has a little bit of a difficult formula with it. We're going to factor out an x. Becomes x cubed minus 8. And this is that little bit of a difficult formula I was talking about. I'm going to write that formula right up here. Formula is this. If I have x cubed minus y cubed, that's going to immediately factor into x minus y multiplied by x squared plus xy plus y squared. And yeah, pretty much is just a formula I end up having to memorize, but I memorize this a little bit of a different way. The reason why I memorize a little bit different way, I memorize the process actually. The process is I see two different cubes, I immediately write their cube roots. That is to say x cubed minus 2 cubed. 2 cubed is 8. That is the x minus y we're talking about there. Effectively, x is x, and y here is 2. Because that 8 really can be rewritten as 2 cubed. Now, the formula says I square this first guy. So I squared the first guy. Then I multiply the two together and change the sign. So I multiply these two together, x times negative 2. It's negative 2x. And I change the sign to positive 2x. For the last one, I square that negative 2. It becomes positive 4. Easy enough. We're all done factoring. Please note in the factoring of 2 cubes, you never have to factor this any further. Letter C, let's continue on. Same exact ideas, kind of as like this step of this problem here. Just got to figure out what multiplies the negative 3 and adds to positive 2. In this case, we're going to have minus 1 and plus 3. Please note, I made these x squareds. That's because this is x to the 4th, and x squared times x squared is x to the 4th. You can always check your work if you wanted to on this by foiling back out and see if you get back to the original. Don't stop here, though. A lot of students forget this is a difference of 2 squares. This guy was a difference of 2 cubes, so it had that formula. This is 2 different squares. 2 different squares goes to the square roots, 1 plus 1 minus. We've been doing that for quite some time. We're all done. Easy enough. I forgot to box this guy over here. Moving on to letter D. Letter D is also a difference of 2 squares. It's just harder to see. We got x to the 6th minus 4, x to the 6th plus 4. And, yeah, not really much to say there. We just have x to the 6th squared is x to the 12th. You know, if I multiplied those together, I get back to x to the 12th. Multiplied these guys together, get back to 16. Works out neat, nice and neat. Don't stop again, though. We got difference of 2 squares again. X cubed minus 2, x cubed plus 2, x to the 6th plus 4. Now we're all done. Letter E. Questions that look like this. We want to instead draw a little squiggly line right down the middle. We know to do that when we have 4 terms total, kind of arranged from highest to lowest. And if we do that, we're going to go ahead and factor out an x squared, from these two. Because there's nothing to factor out of these two, just put a 1, because you're factoring out a 1 from both of them. If you've done these questions correctly, you'll now notice that this is an x plus 14 and this is an x plus 14, so I can factor out an x plus 14 from both. And left over is an x squared plus 1, x squared plus 1. All done. We're going to go ahead and skip that one. It's kind of the same as this one. I don't really need to cover it, and I'm sure there's another one a little bit later. Now we're moving on to the third page. So this third page wants us to continue factoring on these guys. I don't really think we need to spend more time doing it. We did a whole bunch more, and we're going to have more factoring of this later. Let's talk about this remainder theorem instead. Remainder theorem. Briefly describe how you can use long division or synthetic division to determine if x equals a is a 0 of some function f. So if x equals a is a 0, then x minus a is a factor. So if I divide by x minus a, and my remainder is 0, I know I have a factor of the function. In fact, what the remainder theorem basically says is I do f of x divided by x minus a. The remainder is equal to f of a. In other words, if I plug in a into one of these guys and I get 0, it's a factor. If I don't get 0, that's just the y value at that coordinate when I divide by this x minus a. So here we go, doing long division. I don't really want to do long division. I'm going to do synthetic division instead. So with synthetic division, what you're going to do is, because x minus 3 is the factor, 3 is the root, it is the 0, we're going to put that in our box. So we're going to draw our little picture here. 3 goes in the box. And we start here with the coefficients of each one of these. Coefficient, 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 coefficient. 1, 1, negative 9, negative 9. Please be careful. Make sure if there is not an x squared term, for instance, you need to put a 0 here. So just be careful with that. Put the 1 down. Now we repeat the process. What am I talking about? Repeated process. We take this 3, we multiply it by 1, we put the result in between. Now we add. Repeat the process. 3 multiplied by 4 is positive 12. Now we add. Negative 9 plus 12 is 3. 3 multiplied by 3 is 9. Now we add, we get 0. As we learned up here with this remainder theorem, the remainder is 0, which means the y value is 0 if we plug it in. That is to say, if I plugged in 3 into this function, 3 cubed plus 3 squared minus 9 times 3 minus 9, I will get 0. Not that big a deal, but it is true. The result now of this question, these are now the coefficients of our new factored form. What am I talking about? Here's the remainder. Here's the constant. Here's the term with an x. Here's a term with an x squared. X squared plus 4x plus 3. But x squared plus 4x plus 3, that factors. What multiplies to 3 and adds to 4? That's going to be positive 3 and positive 1. I don't know why I said negative. So we have this x plus 3 times this x plus 1. But what we did was we divided by x minus 3. So the factored form of this entire q of x has to be x minus 3 times these two, x plus 3 and x plus 1. And therefore, all the zeros of the function, we'd have x equals 3, negative 3, and negative 1. I don't really feel like doing this because it's kind of the same thing, but you know what? I'll do it anyways because it's got those zeros in it. So we got x equals 3 is 0 again. So again, we got this 3. Boom, boom. I'm going to do this one faster. We got a 1. We got a negative 3. X cubed and x squared are skipped. X cubed, x squared. You got to include all of these or you're going to get these questions incorrect. You got to be careful. 1 comes down, becomes a 1 here. 3 times 1 is 3. Negative 3 plus 3 is 0. 3 times 0 is 0. Add, you get 0. 3 times 0 is 0. Add, you get 0. 3 times 0 is 0. Add, you get negative 81. 3 times negative 81 happens to be negative 243. And if I add that, I will get 0. Again, what that means is that this is our remainder, our constant, our x term, our x squared, our x cubed, our x to the 4th. So we can rewrite this now as x to the 4th minus 81. We can factor that some more. Difference of two squares, we got x squared minus 9 multiplied by x squared plus 9. Don't stop though, this is another difference of two squares. We can finish this off, x minus 3 multiplied by x plus 3 times x minus 3 times x squared plus 9. And just to be a little bit fancier, we have an x minus 3 and we got another x minus 3. X minus 3 squared, x plus 3 times x squared plus 9. And the zeros of this function, x equals 3 and negative 3, this guy is a double. Please note, if we decide to use complex numbers as the root, x squared plus 9 has an additional 0. X squared equals x squared plus 9 equals 0. So x squared equals negative 9. Subtracted 9 on both sides. If I take the square root of both sides, I'm going to get plus or minus 3i. I get I because I had the square root of a negative number. Here are our additional answers. 3i, negative 3i. Easy enough. Not too bad. Let's go on to the next page. Next page, honestly, just more of the same stuff. I really don't think we need to be spending too much more time doing it. We will need to factor like this in the test, but we've already covered 2 of them. Let's move on to number 8 here. So, number 8, just going through step by step. Evaluate f of 0. What does this mean? So if I do f of 0, I get negative 2 multiplied by 0 squared. I don't need to plug in the rest because I'm just going to get 0. This represents the coordinate 0, 0. Because I plugged in 0, my result was 0, so my x is 0, my y is 0. This is called the vertical intercept, the vertical or the y-intercept. The vertical or y-intercept is where we're crossing that y-axis. Always just plug in 0 for x. Determine the leading term and describe the end behavior. So just like the front page, actually, it's exactly the same process. We're going to have a negative 2x squared times an x cubed times a 2x all squared. And that's going to be negative 8, because 2 squared is 4 times 2 is 8. Negative 8x squared, x cubed is x to the 5th, x to the 7th. Boom. Negative 8x to the 7th. Determine the roots of the function. And end behavior, sorry. As end behavior, we got a negative odd. Negative odd looks like that guy from our table on that front page. And finishing the end behavior as x goes to infinity, as x goes to negative infinity, f of x goes to, f of x goes to, and as you go to positive infinity on the right hand side, you go to negative infinity out here, and as you go to negative infinity on the left hand side, you're going to positive infinity up there. Easy enough. What it says is, again, is on the right you go down, on the left you go up. Determine the roots. Roots are nice and simple. We got 0, 2, and then this guy right here, we're going to have to set off to the side. I'll do it right here. 2x plus 5 equals 0. You get 2x equals negative 5, and x equals negative 5 over 2. So you just got to set it equal to 0. Please note, if you want to just do a little trick for this guy, anytime you have a linear factor, you just do this guy over this guy, change the sign in the middle. 5 over 2, negative. Easy enough. So negative 5 divided by 2. This guy is a double. Multiplicity is 0. Multiplicity of 2. This guy is a triple. Multiplicity of 3. This guy's a double. Multiplicity of 2. For each 0, state the multiplicity. I just did that. We got to bounce, we got to cross, we got to bounce. Easy. All right, determine the sign. I do this last. I think it's easier to do that one last. I'm going to do it last. Sketch a rough little guy here. We're going to have a 0 here. A 0 at 2. There's my 2 value right there. And a 0 at negative 5 over 2. Easy enough. End behavior from the last 0 on either side. We have this guy to look at again. We're going down, off to the right. We're going up, off to the left. We cross through only at 2. So we're going to cross through there. After we've crossed through at 2, we have to come back down to this 0. But 0 is a double. It's a bouncer, so it bounces right off. We have to come back down, and it looks like it has to bounce, and does it? Sure does. Double root. All done. Really not much to it. Please note, these guys technically don't actually go to the same y value up there, but meh, good enough. That's a good enough sketch for full credit. Let's go on to the last page. Oh, not the last page. We're just got another one of these questions. It's exactly the same as that front one. I don't feel like doing it, so I'm just not going to do it. Expand. So only really need to do one of these. I'm just going to choose to do the hardest one over here. You can do these a little bit differently if you'd like. But you really just need to make yourself nice, neat, and organized with these. So do a question like this. We're going to take these two and we're going to multiply them together first. We're just going to use our little foiling. So we got x cubed. That's the first times the first, the foiled. Outer, so the outer guys, x times negative 4 is negative 4x. Then we have this 2 times this x squared, so we got plus 2x squared. And lastly, we have minus 8. I'm going to go ahead and put that in the correct order, standard form. X cubed plus 2x squared minus 4x minus 8 times x cubed plus 5. To do the next step, what you really got to do is make yourself nice and neat. We're going to have two different lines here. We're going to have one line for x cubed going to these guys. We're going to have another line for 2x squared going to these two guys. We're going to have another line for negative 4 going to these two guys, and another line for negative 8 going to these two guys. We're distributing. Boom, 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 boom. Distributing a whole lot. X cubed times x cubed is x to the 6th. X cubed times 5 is 5x cubed. I'm going to leave some room here. We can need x to the 5th and x to the 4th. I'm going to put x cubed right here, 5x cubes. Then I'm going to continue on to the next guy, 2x squared. 2x squared times x cubed is going to be 2x to the 5th. Again, I left room for myself. And then I have to continue leaving room because 2x squared times 5 is going to be 5x squared. Oh, no it's not. Oh my gosh, it's going to be 10x squared. 2 times 5 is not 5, it is 10. Jeez. Okay. Easy enough. Next line, we're going to have negative 4 times this guy. We got negative 4x to the 4th. Then we have negative 4 times 5 is negative 20x there. And finally, negative 8x cubed. And we're going to line this up right here, negative 8x cubed. Finally, negative 40. Now we add all these guys together. We get x to the 6th plus 2x to the 5th minus 4x to the 4th minus 3x cubed. I added those together plus 10x squared minus 20x minus 40. I decided to do a second one because I think I did that one a little fast. I'm going to go ahead and do this one over here. I'm going to try to write a little bigger too because it looks like a little small on the screen there. So we have x squared multiplied by x squared. That's going to give you x to the fourth. X squared multiplied by 6x. That's going to give you 6x cubed. And x squared times negative 2 is negative 2x squared. Negative 1 times x squared is negative 1x squared. And again, make sure you line it up correctly. Negative 1 times 6x is negative 6x. Negative 1 times 2 is positive 2. Add them together, x to the fourth plus 6x cubed minus 3x squared minus 6x plus 2. Easy enough. Let's go on to the last one. That last page. So it's the same concepts we've been doing, finishing it all off. By the way, you can just cross out problem 12, not going to show up on that test. Let's go on to number 11 here. So all possible solutions and simplify complex solutions. Show your work for it. Here we go. X cubed plus 3x squared equals 2x plus 6. We need to move everything to the left-hand side, make it equal to 0. X cubed plus 3x squared minus 2x minus 6 equals 0. We're in a situation just like on that front page, not front page, second page, I guess. Got a squiggly line it down the middle. X squared comes out, you get x plus 3. Negative 2 comes out, you get x plus 3. Again, still equals 0. X plus 3 is in both, you can pull that out. What's left over? X squared minus 2. X squared minus 2 equals 0. This guy's easy. X equals negative 3. This guy got to do a little bit of work. X squared minus 2 equals 0. X squared equals 2. So x equals plus or minus rad 2. Final answer is x equals negative 3, positive rad 2, and negative rad 2. Continuing on, same exact stuff. Move everything over, write it in the correct order. 2x to the fourth minus 26x squared plus 72 equals 0. Note there's a 2 in all of these to pull out. 2x to the fourth minus 13x squared plus 36 equals 0. After this, we're going to head and continue factoring. What multiplies to positive 36 adds to negative 13. Might have to do a little bit of thinking here, but it turns out to be negative 9 and negative 4. So 2 multiplied by x squared minus 9, x squared minus 4 equals 0. Got a bunch of differences of two squares. X minus 3, x plus 3, x minus 2, x plus 2 equals 0. X's are 3, negative 3, 2, negative 2, all single roots. Moving right along, these last two, move it over. Got the 2x to the fifth plus 16x minus 12x cubed. And, uh-oh, I did that in the wrong order, didn't I? I need to do this in the right order. Oh, boy. So, yeah, there we go. Let's do this in the right order here. Negative 12x cubed plus 16x equals 0. Again, just move that 16x over. There's a 2x in all of these to pull out, so 2x times x to the fourth minus 12x squared minus, oh my gosh, not 12. You're factoring out a 2. Doing this last couple too fast. Minus 6, and I think that's a plus sign, so that's actually plus 8. Okay, equals 0. What multiplies to positive 8 adds to negative 6? That's going to be x squared minus 4, x squared minus 2 equals 0. And, you know, if you want to be a little bit shifty with this, you could note from here that this guy was the same as this guy, and this guy was the same as this guy. So our x's are right away equal to 0. Positive 2 and negative 2 from this guy, and then positive rad 2 and negative rad 2 from this guy. Last but not least, we're going to have this one, x to the fourth minus 216, x equals 0. There's an x in both of them. We got x cubed minus 8 equals 0. Uh-oh, minus 8. Oh my gosh. Why did I write an 8? That's not an 8, that's a 216. That is a brain failure. I'm getting a little bit too tired here. As it turns out, these are both perfect cubes. We use that same idea from that previous page. Cube root of both of them. Square the first guy. Multiply them together and change the sign. Square the last guy. Equals 0. This guy is x equals 0. This guy is x equals 6. And this guy right here is the quadratic formula to get this equal to 0. I'm just telling you guys right now, that's not on the test tomorrow, so just, forget about it. Okay, great. That's the end of the video, guys. Good luck on this test. Hopefully this was helpful, and see you guys on Monday.